Hello and welcome to EGN 3613. In previous sessions we mentioned briefly rate of return on a certain investment. In this session we will define rate of return. We will go over some methods of finding the rate of return, and we will see the minimum attractive rate of return compared to the internal rate of return, and then we will use that to judge to accept the project or not. So the definition of the rate of return is the relative percentage method, which measures the yield as a percentage of investment over the life of a project. So it's actually a percentage, and it measures the result on the investment. How much do you get back over the life of that investment or that project? To understand the meaning, let's look at an example that will explain the rate of return. In 1970, when Walmart stores went public, an investment of 100 shares cost $1,650. That investment would have been worth $12,283,904 on January 31st, 2002. So what's the percentage that created such a yield on the 100 shares or the $1,650 to become around 12 millions? If we look at the solution, we can see that with the cash flow diagram in time zero, which is in 1970, and that's when the Walmart went public, the shares were $1,650. After 32 years, and that's in 2002, the same amount of shares became $12,283,904. So what is the rate? If we look at the cash flow diagram, and we have the $1,650, and that was at time zero, and we have the return on investment, or the actually cash that we got back in 32 years was $12,283,904, or let me actually write it on this side. $283,904. We can bring this value to year zero, and that's the future. So this is the future value, this is the future, and this is the principal. So we can use the formula, which is F equal to P 1 plus I to the power n, and this is one of the basics formulas that we used at the beginning. Now we know that n is equal to 32, so n is equal to 32. So now I have P, I have P here, F here, and n here. All what I'm missing is the I value. Having this information, we can substitute, and it will equal to 12,283,904 will equal to $1,650 50 multiplied by 1 plus I to the power 32. And then we can take the natural logarithm from both sides or for both sides and find the I based on that, and then I will equal to 32.13%. So as if the rate of return was this percentage. This is the rate of return for the investment that was established, or the shares that were purchased in 1970. To think about it, what caused that rate of return on the stocks or the shares? With the stocks, or the concept of stocks and money market, the increase in the value of the stock or share will lead to what we call at the financial world as stock split. So what Walmart did over the time, over the history of the companies going into public from 1970 to 2002, it splits the share. It did split the shares more than one time. So over the time, the 100 shares became 204,800 shares, and that's why the value of the stocks or the investment that was 1,650 went up to around $12 million. If you compare the return on investment to the return on of investment or investing the same dollar amount in savings account that earns 6% per year, using the same formula to calculate the future value after 32 periods, will result an amount of $10,648 only. So the 6% interest is called the opportunity cost if putting money in savings account was the best you can do at that time. If you don't have any other option, then that will be the opportunity cost, and that will be your return on investment using that saving account. The 6% can be considered as the minimum attractive rate of return. That is your minimum choice. If it's less than 6%, you reject. Any other investment that will give you less than 6%, you will reject it. So if I have a project that will give me over the years, over 32 years, 5% return on investment, you will reject that project because you have another option, which is having it in savings that will give you 6% rate. And that's why we call it the minimum attractive rate of return. Now I will compare the other rate of returns that I have, the other options. If I have investment like the one from Walmart, buying shares in 1970 with $1,650 with $1,650 and having it as around 12 million in 2002, that's within 32 years, and I found that the rate of return was 32.13%, then that's way more than the minimum attractive rate, and that will be a choice of investment or accept to invest in this project or these shares. Why do we use the rate of return more than the present worth to explain the investment? You know, if you look at the two statements in the slide shown here, you will understand that it's easier to understand a given percentage when I say 15%. So the percentage given here will actually give you more meaning than saying just dollar amount for the present worth. When I give you just a net surplus of 10,000 for the present worth, that will not mean anything to me for one reason. When I say net surplus of 10,000 out of investment, for example, of $100, that will considered a big rate of return and a great investment to turn a $100 into 10,000. While if it was out of 10 million, then the 10,000 maybe it's a small amount or a small return of investment on that amount, the 10 million. So it's not considered a good project or a good rate of return. That's why we need to understand more, or we need to use percentage, which makes us understand more if the rate of return was good rate or a good investment or not. The rate of return, also referred to as the return on investment, which could be defined as the interest rate earned on the unpaid balance of an installment loan. For example, if a bank lends you 10,000 and receives annual payment of $4,021 over 3 years, the bank is said to earn return of 10% on its loan of 10,000. You can check the annuity calculation using a principal amount of 10,000 with a rate of 10% over 3 years, which would result in an annual payment of 4,000, to make sure that this is the right amount that we calculated, or this is the right rate of return, which is the 10%, which was stated in the previous slide. The other definition that can be introduced for the rate of return is what we call the break-even interest rate, which makes the present worth of cash flows or cash outflows equal to the present worth of cash inflows. In other words, what makes the net present worth for all cash flows equal to 0. The rate of return can be found using one of the following methods: using Excel financial commands, like we used before, which is the PV, present value, future value, and so on. We have also the direct mathematical solution methods using the formulas that we introduced in the previous chapters. We can use the trial and error method, and we tried that before in one of the chapters. We were trying different interest rates to see if that's the proper interest rate, and then we find the range, the proper range that the interest rate will fall between. Or we can use the cash flow analyzer, which is the online financial calculator that we also introduced in previous session. So starting with the Excel command, you can find the function under financial, and it's called the IRR. The parameters for that function is the cell range and the guess for the rate. So let's actually work on an example to show that. Let's open an Excel sheet, and then let's start with the period. And we have period 0 or times 0, 1, up to 4. Then we have project, and for that project the cash flows will be 1000. We can either write the 1000 as a cost or something that was out of pocket with the negative, or we can use the brackets. The brackets also mean negative. So when you have a bracket and you have the $sign and you put the 1000, it will consider that as negative. So the red means negative. And then you have the $500, also the same, in negative, that's out of pocket. And then I start, after the second, or after the first period, in the second period I start gaining money. So I will have the 800, then I can add the dollar amount, then I will have the 1500, and then I will have the $2000. So this is the cash flow that I have for this example. Now let's find the rate of return. So I will say that IRR will equal, and then I will go to this cell, and I will put the equal sign, and as soon as I put the equal sign I have the functions here. I can either click on the function or I can write directly here IRR, and it will find it for me. If you would like, you can click on functions, and from functions you can select financial, and from financial you can scroll all the way down to the IRR, select and say OK, and that will give you the values. So the values is first the range. This is the range that you need, so you can just click on this one here, this corner, and once you click it will ask you for the range, and you can just select the range like that and press enter, and it's already been selected. Then you can add a guess, and you can just add as 10%, and this will be your guess, and then click enter, and you will get that the return on investment or rate of return will equal to 44%, just to be able to get these amounts out in the second, third and fourth year. So this is an example on how to use Excel sheet. We can use the other computational methods, which is direct solution, and the direct solution could be using the logarithm like we said before, and we used that in a previous session or previous PowerPoint presentation. And we have also the quadratic, and I will go over these in a minute. We have the trial and error method, and we have the computer solution method. So let's start with the first method, which is direct solution method. We have two projects, project A, project B, and we have the cash flow for each one of them. So we will use direct solution as we stated before. We have either the logarithmic approach or the quadratic approach under direct solution. That's why I will use different direct solution for each project. So for project A, we will use the logarithmic approach, and then in project B we will use the quadratic. In project A, P, the principal, is equal to 1000. The future value is equal to 1500, and the number of periods is equal to 4. And I'm trying to find the value of I. This is the rate of return. Now to do that, we use the formula, which is P is equal to F multiplied by 1 plus I to the power minus 4. And this is the formula that we used since chapter 2. Then we divide both sides by 1500. Dividing by 1500 will yield 0.6667, which will equal to 1 plus I to the power minus 4. Taking the logarithm for both sides, then dividing by minus 4 will give me a value at the end of 10.67%. And that will be the rate of return for project A. For project B, which is a totally different cash flow, the project will use quadratic direct method solution. And to do that, we will assume that 1 over 1 plus I is equal to X. 1 divided by 1 plus I is equal to X. Based on that, we will convert the 1 over 1 plus I, this one, into X. 1 over 1 plus I squared is X squared, and so on. And that's how we got these values. The 2000 did not change. This value became 1300 X, and this one became 1500 X squared. And that should equal to 0, and that's the net cash flow or net present worth for the cash flow. Solving the quadratic equation, we will get X either equal to 0.8 or minus 1.667. Replacing the X here, substituting X with 0.8, we will get I is equal to 25%. Replacing the X with minus 1.667, we will get an I equal to minus 160%. Since this is a negative, we will discard this value, and we will take I as equal to 25%. And that will be our rate of return. So we can either use the logarithmic approach or the quadratic approach, and those are two different approaches that can be used in the mathematical solution to find the rate of return. For the third method, which is the trial and error method, we can use the information provided in project C, assuming an interest rate I, then calculate the present worth of its positive. If it's positive, then I will increase the rate. If it's negative, then I will decrease the rate until I find the proper rate. So it's like a trial and error process. Actually, with the trial and error and finding the positive and negative, we can define a range and then start narrowing and suggesting something in between until we get the proper rate. In this case, with 15%, we found that the value is positive and it's 3,553. That's the present worth, net present worth, and it should be 0. We are looking for a 0. when we decreased it, we increased the interest rate to 18%, we decreased the value to minus $749. So for sure the value will be between 15% and 18%. And like I said, with the trial and error, we found that the value is 17.45. Another way is to use this formula, which gives you the I, or calculate the I through the first interest rate that's been suggested plus the difference between the first interest rate, which is the 15%, and the 18%, that's 3%, multiplied by the value that we got from the 15%, divided by the summation of the two values, and that will give me 17.45%. The fourth method is the online cash analyzer. We can implement this method on the fourth project and get the rate of return using the analyzer. Let's do that. Let's fill in the amounts for the fourth project, and we have here $10,000 of cost, initial cost, and then we have a gain of 20,000, another 20,000, then we have 25,000, and we can just compute the rate of return, and it will give me a rate of return that's 196.07%, and this is the rate of return. This is the rate of return. My initial cost was only $10,000. That's my capital cost, and then I started gaining 20,000, 20,000, and 25,000, and that is again, huge rate of return. That's why we got 196.07%. No matter which method do we use, we need to conclude, or we need to know that if the rate of return is greater than the minimum attractive rate of return, then we need to accept the investment. This rule works with simple interest rate or simple rate of return, but if we have multiple rate of returns, then that will not work. And when we say multiple rate of returns, that means the values of the cash flow fluctuates or changes over time. And we will look at some examples. What do we mean by multiple rate of returns, and how would we make the accept reject decisions? Let's look at that. For a simple investment, the cash flow are negative, and only one sign change occurs in the net cash flows series. For example, we have the minus 100 at the beginning, which is the capital cost, and then we start getting the values in positive 250, 300, so one negative and then positive, and that's why we have a simple investment, or one rate of return, which is a unique rate of return. With the non-simple investment, the initial cash flow are negative, but more than one single or one sign change in the remaining cash flows series. So for example, we have $100 at the beginning, which is the capital cost, then I will gain 300, then I will incur some other cost which is minus 120 and so on. So it's negative, positive, negative. And in this situation, actually there is a possibility of multiple rate of returns. We can also judge from the change of signs which project in the list here is simple and non-simple. In addition, we can use the graph on the side to decide which one is simple and which one is not simple. So if you look at project A, for example, we have a negative sign here. So we have negative sign, until now no change, and then positive, positive, positive. That means I have only one time change. That is simple investment. If you go to the graph, you can see that the project was in negative, then it turned into positive. That's why we have one change in the sign, and that is a simple investment. While if you go to project B, we have negative 1000, then 3900, then negative 5030, then positive 2145. That means it fluctuates like that, sometimes in positive, sometimes in negative, again in positive, negative, and so on. That's why we have multiple rate of returns, and in this case it's non-simple investment. It's a non-simple investment. For project C, it's a borrowing case where we have positive because I took from the bank money, so I put money into my pocket and started making monthly payment. That's why we have one change in the sign, positive, negative, 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 which means that it's simple borrowing, borrowing. And the same here, from that graph you can judge that it's simple borrowing or simple investment, and you can decide which one is one rate of return, unique rate of return, or multiple rate of returns. Let's look at the example shown in this slide. The cash flow show out a pocket of 1000. Then we have a gain of 2300 at the end of period 1. Then we have out of pocket a gain of 1320 at the end of period 2. So we can use the present worth analysis to find the rate of return that will make the net worth equal to 0. And this is our goal, is to find I that will make the net present worth equal to 0, and that will be my rate of return. We can use for this, if we would like to do the mathematical method, we can use the quadratic approach. And using the quadratic approach, we change the 1 over 1 plus I into x. So now I have quadratic equation with x and x squared that it will equal to 0. We'll find the value of x. Finding the value of x will, as soon as we substitute that in the equation, x is equal to 1 over 1 plus I, we find I, and I is equal to 10% or 20%. Actually, we can graph that and we will have it exactly like this. Because it's quadratic, we will have shape like that, and we'll have 2 points, 10% and 20%. Analyzing the cash, we can see that the cash borrowed, released or released from the project is assumed to earn the same interest rate through external investment as money that remains internally invested in the pool. We are assuming that the MARR is exactly 20%, which means that the company will be able to invest, but if the MAR is 15%, then the assumption used in calculating I is no longer valid, which means that neither 10 or 20% are true IRR. In this case, if we encounter multiple rates of return, then we abandon the IRR analysis and we use the present worth criterion, which will assist in making the proper decision in to accept or reject the project. Actually, we can look at the graph and judge. In the first graph, most likely the IRR is equal to rate of return, which is just a unique one, and if it's unique, the IRR, if it's greater than the minimum attractive rate, then the investment should be accepted. It's simple to judge, simple to use. If the plot looks like more complicated, like the second one here, then the rate of return will not equal to the IRR, and in this case we abandon the IRR method and use the present worth method to judge accepting or rejecting the project. That will be all for this session. If you have any questions, you can email it to me. Thank you and have a great day.